A transfer function is the ratio of the input to the output of a system. So if you call the transfer function h of s, which is output over input, then you would write that as y of s over x of s, where y is the output and x is the input. The impedance of a resistor is R. The impedance of an inductor is SL. The impedance of a capacitor is 1 over SC. So to rewrite a circuit in the frequency domain, complex frequency domain, which is also called the Laplace domain, from Laplace transforms, then the resistor would be R, the capacitor would be 1 over SC, and the inductor would be SL. And if the output is the voltage across the inductor, one way you could do these problems is Kirchhoff's current law, right? You could also use KVL, but KCL actually makes more sense. So if I call the input from the source I of S, and the output can be across any of these. So you could have I of S, current going in, is going to equal to V naught of S over R plus V naught of S over 1 over SC plus V naught of S over SL. So I of S would be V naught of S times 1 over R plus SC plus 1 over SL. Then to get a common denominator, that would be V naught of S times, if I multiply by a common denominator, which would be SLR. So that means that this is going to be SL plus S squared RC plus R over SLR. Okay, let's make sure that's right. You multiply this one by R over R. You multiply this one by SLR over SLR. That's S squared LRC. And then multiply this one by SL over SL to get SLR. Multiply this one by LR over LR. And multiply this one by R over R. Okay, please check that this is correct. Okay, so then if your ratio was V naught of S over I of S, so voltage over output, voltage output over current input, then that would be SLR over S squared LRC plus SL plus R. So now, if we want this to be the ratio of voltage VI over voltage VN, that's actually the impedance, right? So V naught of S over I of S, this is actually the impedance seen looking in from the voltage source with respect to the current source. All right, so that's just like if you wanted admittance, which would be I of S over V naught of S, that would be the reciprocal here, S squared LRC plus SL plus R over SLR. That would be the admittance. So this is admittance, and this is impedance. But now we need a relationship between V naught and VI, all right? So V naught and VI are actually in parallel. So V naught of S is equal to VI of S.